Here's how to determine the transformer loading after installing a power factor correction capacitor bank. We start with the given information. The transformer rating is unknown, the motor voltage is 480 volts, the motor power factor before correction is 0.8 lagging, a power factor correction capacitor bank is rated at 100 kVAR, and the new power factor after correction is 0.95 lagging. First, we calculate the motor load before correction. The motor load in kilowatts equals the motor power in kilovolt amperes times the power factor. Therefore, the motor power in kilovolt amperes equals the motor kilowatts divided by the power factor. This gives us the motor power in kilovolt amperes equals X divided by 0.8, where X is the unknown motor kilowatt load. Second, we calculate the transformer load before correction. The transformer load in kilovolt amperes equals the motor power in kilovolt amperes divided by the transformer efficiency. Assuming a transformer efficiency of 90%, the transformer load in kilovolt amperes equals X divided by 0.9. Third, we calculate the transformer load after correction. The new transformer load in kilovolt amperes equals the transformer load before correction in kilovolt amperes times the new power factor divided by the old power factor. Therefore, the new transformer load in kilovolt amperes equals X divided by 0.9 times 0.95 divided by 0.8. Fourth, we solve for the unknown motor load X. We know that the power factor correction capacitor bank supplies an additional 100 kVAR. Therefore, the new transformer load must be 100 kVAR less than the transformer load before correction. This means that the new transformer load in kilovolt amperes equals the transformer load before correction in kilovolt amperes minus 100 kVAR. Therefore, X divided by 0.9 times 0.95 divided by 0.8 equals X divided by 0.9 minus 100. Solving for X gives us X equals 100 kilovolt amperes times 0.95 divided by 0.8, which equals 118.75 kilowatts. Therefore, the load in the transformer after the installation of the power factor correction capacitor bank is X divided by 0.9, which equals 131.94 kilovolt amperes.